Welcome, geometry students, to class today. Hope you guys are doing well. Hope you're ready to learn some math today. I am making this video during prime time, family time, so if you hear some background noises, my kids will be running through the house and stuff like that, but it should be fine as in terms of being able to hear what I'm saying. So let's go ahead and get started. Let's look at some announcements here. Voice is still a little raspy, so just kind of put up with that, but here we go. There will be a test on Friday. Lord willing, I will be there to administer that test, so I should see you guys on Friday. Because there's a test on Friday, there will be a review sheet on Thursday. I'll give you more details about that later. If you do the review sheet, don't forget, Haley, you're kind of new to me as a teacher still, but if you do the entire review sheet and turn it in, you get 5 bonus points on your test. Please turn in yesterday's homework. Now, Jake and Martin already turned theirs in. So that would leave Jason. I know she was absent yesterday. Azu, please turn in yesterday's homework. And Haley, please turn in yesterday's homework. It was lesson 8.6. Not sure what the assignment was, but you should have that from yesterday. And Jason, if you're there today, let me know about the makeup quiz. You don't have to take it. You're welcome to skip it. Right now, I just want you caught up and getting ready for the test. But let me know what your decision is on that. And Haley, you were all caught up, so good job there on turning in the lessons you were behind on. So with that in mind, let me go ahead and get a drink, grab your notebooks, pens, pencils, papers, calculators. Let's go ahead and get started. Today will be the last lesson in Chapter 8, so we're finishing up Chapter 8 today, and it's been a pretty easy lesson. I mean, areas of squares, rectangles, parallelograms, trapezoids, I mean, all of this stuff, triangles, pretty simple. We have learned how to find the area of many different polygons in this chapter, okay? And so that's been pretty simple. We're going to finish up the chapter today learning or reviewing, because you probably knew all this information already that we've covered this chapter, but we're going to finish up the chapter learning or reviewing how to find the area and how to find the circumference of a circle. How to find the area and the circumference of a circle, okay? So your heading today is area and circumference of circles, and the date today, if you want to write this down, I encourage you to do that. Today is the 19th, February 19th, 2014, and again, your heading today is area and circumference of circles. I'm going to go fast, so pause the video when you need to. Radius. What is radius? You need to know what radius is. This is not going to be on your test, so you do not need to memorize this. So if you know this already, then don't worry about writing it down. I'll leave that up to you. But radius is a segment that starts here in the middle of the circle. It has to start at the center, and it goes until it touches the edge of the circle. That segment right there is called the radius of a circle. It starts at the center, and it goes until it touches the edge of the circle. This is called the radius of a circle. You need to know that, all right? The diameter. Now, you do not need to, well, let me back up. I just said you need to know that. I'm not saying this will be on the test. This definition will not be on the test, but you need to know what a radius is so you can work the problems out. This definition right here, diameter, that will not be on the test. It will not be a fill in the blank. However, you still need to be familiar with what it means. The diameter is the distance across the circle through the center. So we have a segment here that goes all the way across the entire circle, and it must pass through the center. And this line right here, it goes from one edge to the other edge of the circle, and it crosses through the center. So we call that line right there the diameter of the circle. The diameter of a circle. Okay? Moving on. So the radius, in case you haven't figured this out, then the radius is always half the length of the diameter. So if the diameter of this circle was 12, let me change what mode I'm in here. If the diameter of the circle was 12 all the way across, then the radius would be what? 6, half of that. Okay? All right, the radius is always half the diameter. Let me get a drink and let's continue on. Having gone over these definitions, let's go ahead and get started with finding the circumference of circles. I'm not sure why. I think that was just accidentally left there from a previous slide. There we go. So let's go ahead and take a look at circumference of circles. Here's the definition of circumference. You do not need to know this for the test. I'm not going to put this on the test as a fill in the blank, but you still need to know what circumference is, okay? Circumference is the distance around the circle. Circumference is the distance around the circle. Now, I do believe I probably wanted this circle right over here. Okay, now, listen to me please. If this is a circular swimming pool in your backyard, like this, a circular swimming pool in your backyard, and you wanted to put a fence around the pool, you would not find the area of the circle. No, you would find the circumference of the circle, because the circumference of the circle is the distance around the circle. So if you were going to put a privacy fence around a circular pool in your backyard, you would find the circumference of the pool, or the distance around the pool. So you would know how much fencing to buy. That's what circumference is. It's the distance around the pool. Okay? Now let's go ahead and continue on. Let's find the circumference of the circle below. It has a radius of 4 inches. Now, you need to know the formula for finding the circumference of a circle. The circumference of the circle is so easy. Pi d. That's it. That's all you got to do. If you can multiply two numbers together with a calculator, you can find the circumference of a circle. Now, pi, let's go ahead and slide this over. I believe we know by now that pi, we're going to use 3.14 to represent pi, and D stands for diameter. Now, come on, students. You guys are seniors and a sophomore. This is pretty easy. Is this the radius from here to here, or is that the diameter? Well, that's the radius. We have a radius of 4 inches. So if the radius is 4, what's the whole diameter going all the way across? If this is 4 from here to here, then the whole diameter is what? 8. So what do I put for my diameter right here? 8. It's that easy. If you want to find the circumference of the circle, all you need is the diameter. That's all you need. And then you simply multiply pi times the diameter, or in other words, 3.14 times 8. If you type that in correctly, you will get 25.12 inches. Now notice it's not square inches. We would say square inches if you were finding the area. We're not finding the area, we're finding the circumference. So with that in mind, the distance around the swimming pool, or around the circle, and obviously a swimming pool would not have a radius of 4 inches, but you get my point. The distance around this circle is 25.12 inches. That's the distance around the circle. Let's go ahead and try another problem. Find the circumference of the circle below. Now you can work ahead or watch me. That's totally up to you. The formula for the circumference of a circle is C equals pi times diameter. So for pi, I'm going to substitute 3.14. And for the diameter, I gave you the diameter. It's 16 feet. So if you can simply take a calculator and multiply it times 16, you will get the answer, and the answer would be 50.24, and we're dealing with feet. One little mark right here means feet, so the circumference is 50.24 feet. Okay? Now, it's not square feet because we're not dealing with area. Sorry, students, excuse me. Let me get a drink here real quick. All right, so circumference of a circle. It's the distance around the circle, and the formula is pi d, and the answer to this problem is 50.24. Now let's continue on. Let's take a look now at area of a circle. All right, area. Area of a circle, by the way, this will not be on your test. You do not have to memorize this, but you better know what it is. But I am not going to put this on your test as a fill in the blank. Area of a circle, the amount of space that is inside the circle. That's area of a circle, the amount of space inside of a circle. So for example, that's not a very good circle, but if you had a circular pool in your backyard and after you had purchased your fence that went around it, let's say you wanted to purchase a solar cover, a cover that went over the pool. Okay, so you wanted to buy a heat or a solar cover that goes over your pool. Then area would be all of the space inside of the circle. That's what area is. So if you wanted to find how big you wanted a pool cover to be, you would find the area of the circle pool. Okay, and then you would know how big of a pool cover to purchase. All right, so that's what area is. It's the space inside of a circle. Let's go ahead and try one of these problems. Let's find the area of the circle below that has a radius of 7 yards. Now, in order to find the area of the circle below, we of course need our formula. And here's the formula for finding the area of a circle. Pi r squared. Okay? That's it. So students, if you can take a number and square it with your calculator and then multiply it by 3.14, you can solve these problems. It is really, really, really simple. So I want you to find the area of this circle, the area. Well, here we go. First of all, for pi, I'm going to put 3.14. For my radius, I'm going to put 7 because my radius is 7. And then, of course, you bring down your 2 right here. Don't forget to bring down your power of 2. So I have this. Now, you do not multiply 3.14 times 7 first. You first square the 7. So now I have 3.14 times 49 because 7 times 7 is 49. And then 49 times 3.14 is 153.86. Now that would be square yards because we're dealing with area now. So we would simply say 153.86 square yards. So there you found the area of the circle, or in other words, you found the space. You found the amount of space that's inside the circle. Okay? And that's what area is. Okay? All right, let's go ahead and try one more of these. Then we're going to move on to actually some pretty difficult math. So I hope you guys are ready to think. All right? Let's try another one. Let's find the area of the circle below. So we use the same formula for area. Area equals pi r squared. You can work ahead or watch me. First of all, for pi, I'm going to substitute 3.14. Now be careful with the radius. I've given you the diameter. So the whole length all the way across the circle is 26. So the radius only runs from here to here. So half of 26 would be what? 13. So the radius is 13. Now don't forget, you square 13 first. And when you square 13, I'm doing this in my head. I believe you get 169. Let me check that. Yes, 169. And then you multiply 169 times 3.14. And the area of this circle would be 530.66. Now remember, it's area, so it would be square. Now look, I intentionally did not label this. Notice there's no feet or inches or yards or meters or anything like that. So when you don't know what the unit of measurement is, then what you put is square units. So the answer would be 530.66 square units, because you don't know if it's feet or yards or inches or whatever the measurement might be. So guys, that's pretty simple. If you can remember, circumference of a circle is pi d, area of a circle is pi r squared, then you should be able to solve these types of problems. Now, let's just see how smart you students are, okay? Let's try something a little challenging here. The area of a circle is 38 square feet. I want you to find the diameter and the radius. Okay. Well, we know we're dealing with what? Think carefully here. We know we're dealing with what? Area of a what? circle. So more than likely we're going to use this formula right here. Area equals pi r squared. Now, for area, I'm going to substitute 38 because I said the area is 38. For pi, I'm going to substitute 3.14. And then I'll leave r. Now students, 3.14 is being multiplied times the radius squared. So if I want to get r by itself to see what the radius is, I'm going to divide both sides by 3.14. Now over here on the right side, these will cancel out, leaving you with r squared. On the left side, if I take 38 and divide it by 3.14, and you're allowed to round, that's fine, you're going to get 12.10. All right? Now, we should know when we have r squared and we want to get rid of this 2 right here and make it just r, we take the square root of r squared. But if you take the square root of one side, you must take the square root of the other side. We've learned that before in Algebra 1, Algebra 2, Bridge Math, all of that. Now, the square root of r squared is r, and the square root of 12.10 is going to be 3.47 or 3.48. Now, I will admit that in the past, you were taught whenever you take the square root of both sides, you put plus minus in front of this. But remember, we're dealing with the diameter and the radius, and how can a measurement ever be negative? It's not possible. Let me get a drink here. So we know radius has to be positive. So the radius would be 3.48. So good, you found the radius. Now hold it, think about this. Remember the diameter is always twice as big as the radius. So if I take 3.48 and multiply it by 2, now I know the diameter is 6.96. Remember, the radius is always half as big as the diameter. Or in other words, the diameter is twice as big as the radius. Okay? So with that in mind, don't forget we're dealing with square feet. So your radius is 3.48 feet and your diameter is 6.96 feet. There we go. Okay? So pretty simple. It's not hard at all. Okay? All right, let's continue on. Let's try another problem. Now this is going to get really complex, so please pay attention. I am not going to give you this on your test. You do not have to memorize this. But you need to know what it means so you're just used to this, okay? A central angle is an angle whose vertex is at the center of a circle. And I've given you an example right here. Here's the center of the circle right here. And notice the vertex of the angle. The vertex of the angle is right here at the center of the circle, okay? So this would be what we call a central angle, because the angle has its vertex at the center of a circle. Make sense? All right, now let's continue on. Let's talk about a sector. A sector is a region of a circle determined by 2 radii. Let me show you what I mean. If a sector is the region of a circle determined by 2 radii, then it just means this. When I say look at a certain sector, it would be the shaded in area right here. There you go. And I know it's not perfect. I know I've gone outside the lines a little bit, but you get the idea. The outline of the sector would be like this. Here's the outline. There we go. So a sector is a region determined by 2 radii. And here's one radius. Here's the other radius. So we call that radii. That's plural for radius. And it's the area in between. So that's what a sector is. So let's review. An angle is a central angle is an angle whose vertex is right at the center of a circle. And look, whenever you have a central angle, then you're also going to have a sector, because the sector is this area in here between the 2 radii. Okay, so let's go ahead and try 2 really hard problems, 1, 2, and then we'll talk about your homework, and that's it. Okay, so not too bad of a problem, not too bad of a class period today. Okay, write this in your notes, please. I want you to find the area of the shaded sector. Man, that's going to be challenging. I want you to find the area of the shaded sector. Let me break it down for you in steps. If you'll memorize these steps, let me get a drink, students. Hold on. Sorry, guys. Still a little sick here. If you will memorize these steps, they will work every time. Now, the first thing you do is write this down, please. You find area of the whole circle. That's the first thing you do. Got it? That's the first thing you do. The second thing you do, now watch this, is you find the fraction. Now stick with me and listen. I'll explain this later. You find the fraction of the shaded area. And then step 3, you just multiply steps 1 and 2 together. Just multiply them together. Now, I think it'd be smart if I quickly pull these steps over also to the other page so we have those. So give me just a second to do that. All right, there we go. You guys ready? We can do these 3 steps easily. In fact, you probably already know how to do step 1. Find the area of this whole circle. How do you find the area of a circle? Well, we just learned that. Area equals pi r squared. So to find the area of the circle, 3.14, my radius is 9, so 9 squared. Well, 9 times 9 is 81. And then if you take 81 times 3.14, you will get 254.34. Okay? So that's easy enough. I mean, we just learned how to do that a second ago. So step 1, whenever I ask you to find the area of a sector, you first of all find the area of the entire circle. So I'm going to put that right there, put parentheses around it. There's the area of the entire circle. Okay? Now let's go ahead and move on to step 2. Now, to find the fraction of the shaded area, it's really easy, guys. Notice how I have 120 degrees right here? So we know this central angle right here is made up or formed by an angle of 120 degrees. So here's what you do. You always take the angle inside the sector, in this case it's 120, and you put it over what? What do you think you put it over? Wouldn't you put it over the entire angles in a whole circle? And what's the entire angles inside of a circle? 360 degrees. So you always take the angle, that's the angle of the shaded area of your sector, and you always put it over 360. So let's reduce, cross off your zeros. 12 goes into 12 once, 12 goes into 36 3 times. So there you did it. You found the fraction of the shaded area, and the fraction is 1/3. And now look what you do. You take your calculator and you multiply steps 1 and 2 together. So you take this number times this number and you're finished. It's that simple. So 254.34 times 1/3 is going to give you this right here. 84.78. Now look, what were we finding? We were finding the area of the shaded sector. And area is going to be in square units. Now my radius here, my 9, it doesn't say feet, inches, or yards or anything, so I'm going to call my answer units squared because it is area, so it will be squared. And that might be helpful. Maybe you would want to section off part of a garden, a circular garden, and you wanted to know how much mulch to buy to cover this part of the garden. You could use a problem like this to help you find the area of the region or the sector that you want to spread mulch over. Okay? One more problem and we're done. Feel free to work ahead on this problem if you would like to. Okay, here we go. Find the area. That's not going to work, is it? Here we go. And how can we do this? Let's see here. I think we got a little bit. That's not too bad. There we go. Okay. Now, we're going to find the area of this shaded sector. Okay? So, with that in mind, you can work ahead or watch me. Here we go. First of all, step one, you find the area of the entire circle. And actually, I'd like to do that. I would like to do that. And let's pull this whole thing down here. And then we'll have a little more room to work with. Okay, so we're going to find the area of the shaded sector. Well, I gave you 3 steps. Anytime I ask you to find the area of a shaded sector, first of all, you find the area of the whole circle. I'm going to go pretty fast now. We should know how to do this. Area of a circle is pi r squared. So for pi, I'm going to substitute 3.114. My radius is 3, so 3 squared. Well, 3 squared is 9, and 9 times 3.14 is 28.26. So the area of the entire circle is 28.26, and I'll put that right up here. Now, step 2 says find the fraction of the shaded area, and I taught you how to do that. What I taught you is whatever the angle is in your shaded sector, in this case it's going to be 70, that always goes over the entire circle, which is 360. Okay? So you always take the angle inside the shaded sector and you put it over 360. Cross off your zeros, and you know the fraction of the shaded area is 736. And now you simply multiply the last 2 together. So we take 200, or 28.26, times 7 over 36. And I think I've messed that up. Hold on one second here. And you're going to get 5, if you do it correctly, you're going to get 5.495. Now we're dealing with area, so it's going to be square units or units squared. That's it, guys. You can do those. If you'll memorize those 3 steps, you will be able to find the shaded area of a given sector. Okay? Now, I know it's a Wednesday, and I know I'm going to give you a review sheet tomorrow with no notes. I'm going to trust you right now not to work on science or history or the Bible or English or whatever. You need to work on math during math class. So I want you to work on this assignment, okay? You do not have to finish it. It's a Wednesday night, but you are going to turn in what you got done. So go ahead and get started on this. You can go in order or you can jump around, whatever you would like to do. Okay? You can go in any order you want, and there's no bonus points if you finish it, but if you'd like to finish it, that's totally fine. You do not have to. Now the help video is this right here. That's the help video, okay? Geometry 8.7 homework. But remember, this is a video from when? This video right here I'm circling is a video from last year. So please ignore everything it says about tests, quizzes, homework. Just listen to it as it helps you work out the problems, okay? Again, guys, I apologize. My voice is pretty raspy. You've been troopers listening to me. I hope you guys have a good day, and I hope you're doing well in your math. If you have any questions, call or email, and there will be a review sheet tomorrow and a test on Friday.